So today we are going to discuss about the ping
Yeah,
packet internet group पर sorry. Hmm. So what is ping? You might pinging any whenever you are off whenever you work in an office, you
mm,
might have pinged to someone to some
yeah,
IP, not pinging to on WhatsApp or on
yeah,
the Teams, like command prompt or whenever you log in a router any device, um, you may ping, right?
yeah. Trying to check whether the device is online or not.
Correct. So ping is a tool to verify the connectivity between the two devices. A device is here and B device is here. If you want to verify the connectivity or to test the connectivity, just the connectivity is established with B or not, then you have this type of tool, ping. You just open anything and ping BIP. If B is connected with you, then B will reply you. Even I can ping whenever I open my command prompt, I can ping to google.com. So Google is replying me, ping Facebook. Facebook is also replying me. Even you can ping some IP also. IP also replying me. IP config. This is the IP address on my adapter,
Yeah,
Wi-Fi adapter. Okay, that was on VM type. Here, my Wi-Fi adapter. And my gateway is default gateway 31.1. This will be on my modem side. Even you can ping this IP. I'll tell you these entries, how these entries get established in the ARP table. But you can see there are the few MACs and few IPs are there, so we can ping those IPs. So it's just a tool to verify the connectivity. So what happens behind the picture here? Suppose there is a network. Let me draw a topology. Okay, the three routers are there, and they are connected. Here I need to configure the subnet. Suppose 12 R1 R2 is there, then I'll mark 12. 12 mean R1 R2 1.1.0 slash 24 network we have configured on this segment. Okay. In the same way,
Yes, sir.
R2 R3, then it would be a 23. And here one network is there 192.168 1.0 slash 24. Here 2.0 slash 24. Even you can do and here you have done 192, 168, 1.1, 1.2, 2.1, 2.2. It will have the device will have some MAC address. Suppose AA, BB, CCC, and DD. Do in this way.
पापा
Hmm.
एक सीट दे दो मुझे ये वाली दूसरी मैं ड्राइव करूंगा
So here 192, 168, 1.1 is there. 1.2 is there. Main the whole subnet is there on the left side. On the right side, 192.168.2.0/24, 2.1, 2.2. They are on these laptops. Fine. They further connected with switch 1 and 2. Switch 1 is connected with the router, switch 2 is connected with the router 3. So here, definitely you will have to give some IP. Suppose 1.100 you have given 192.168, 1.100. Here 2.100. And that would be the gateway for these devices, right? Because here devices are connected in a one LAN network. So if they want to connect outside, what will be their default gateway? Their default gateway would be the router, this router IP. Their default gateway would be this router IP, not this one. This one, because this is connected with the LAN. This interface is connected with the LAN. So this will be the default gateway. Got it?
Yes, I got it, sir.
Okay. Hmm. You do not have any issue in this topology, right?
No, sir.
Okay. So now if this guy wants to ping 2.1, if this guy wants to ping 2.1, what will happen? So what will happen from the suppose PC1 ping he is going to initiate ping 190 to 168 2.1. Okay. Where is that icon? Hmm. So ping 192 168 2.1. What ping will do? Ping initiate ICMP protocol, which works on the layer 3. So ICMP will come into the picture. Internet Control Messaging Protocol. It's a layer 3 protocol. It works on the layer 3. Works on layer 3. So ICMP will create a request message. Okay. Request for what? It is pinging to words 2.1. Okay. Request message created. Then on the same layer 3, the OSI layer 3, there is a protocol which runs. The protocol name is IP protocol, right? So it will, your request, ICMP request message will be handovered. It will be handover to IP protocol on layer 3 itself. What layer 3 will do? Here IP protocol works.
Layer 3 will check route map whether it will
IP
be.
IP protocol what will do?
It will check on the router like whether
No.
it
It
is
will
directly
apply
connected.
IPv4 header.
Mm-hmm.
It will apply IPv4 header. So request came plus IPv4 header. IPv4 header. What we call it? We call it packet at layer 3. So request in the IPv4 header, what will be your source IP? There are the many fields in IPv4 header. We will discuss that also. So, but two fields are very important. Source IP and destination IP would be there, right? So if you
निकलवा दो मैम ने की थी पापा
if you do it, just a minute.
Yes, sir.
So request plus source. What is the source IP here? 192.168.1.1. What is the destination IP? 192, 168, 2.1, right?
2.1, yeah.
Now it will hand over to the data link layer.
1, 2, 3, 4.
On data link layer,
1, 2, 3.
ARPA protocol works. ARPA protocol what will do? It will apply it, or it will add Ethernet header.
Papa?
So request. So request is coming. Sorry. Okay, so sorry. ARPA protocol works on the layer 2. It will add what? It will add Ethernet header. So in the Ethernet header, what will be there? So your packet was coming. Now it will add the MAC addresses, source MAC address
Source MAC
and
address, destination MAC
destination
address.
MAC address.
1, 2, 3.
So source MAC address it has, because your PC knows his own MAC address AA. Plus what about the destination MAC address? It doesn't know about the destination MAC address, right? Is unknown. Destination MAC address is unknown for this PC. How can this PC know about the remote MAC? It can't. So what will happen? This process will be on hold for few time, for few moment. So now the responsibility is on the ARP protocol to get or to find out the destination MAC address. ARP will come into the picture. Let's find out MAC address of 192.168, 2.2.1, right?
ऐसे बता दो एक मिनट में.
What the flag was that? बेटा मैं करा दो 10 मिनट फिर मैं करा दूंगा ये मत ही कर लेना मैं ये नहीं चल रही हूँ
बस ये तो बताने हैं. सिर्फ लिख के दे दो 1 मिनट में. एक बॉक्स में.
sorry my kid was there. Okay, so let's find out the MAC address of 2.1. This is the responsibility of ARP protocol, address resolution protocol, which works on the layer 2. ARP works on layer 2. So now ARP will create a request message for what? To find out the MAC address on this device. Wherever this IP is configured, we need the MAC address for that device. So what will happen? ARP will create a packet source IP. It will add the source IP and destination IP at the layer 2 itself 192.168.1.1. Destination IP is what? 192.168.2.1. For this, we have to find out the MAC address. Plus, it will add the source MAC in this request message itself. Source MAC address is AAA and destination MAC address is unknown. It doesn't know. So what will ARP will do? It will 00000. Okay, because it's a unknown. We don't know the ARP. We don't know the MAC address for this IP 2.1. So let's fill out the 0000. It's mean unknown. Now this message will hand over to the ARPA. ARPA will add Ethernet header as we discussed earlier. So it will add the MAC address with the request message which was created by ARP protocol AA plus the destination MAC address is it will know like ARPA knows if any message coming from the ARP to find out the MAC address, then it would be broadcast. It would be broadcast. FFFFFF. So it's mean broadcast. Let's have a broadcast message. But there is a glitch now. I tell you what. This process will be there. This process will be there. There is a trick. This process will be there. If
Sir, how come it knows the, I mean, destination MAC address before?
this
Destination MAC address will be FFF, right?
This no, this is not a destination MAC address. So ARPA, what ARPA knows? ARPA knows, okay, ARP is sending me a ARP request message. Okay, which
Mhm.
I need to be broadcast. So this mean broadcast because he doesn't know the MAC address.
Hmm.
Okay, so it will be broadcast to all. FFFF mean broadcast to all. Send it to all.
So it says that whichever having this destination IP, please reply.
Right. But there is a trick now, I tell you. This process will be applicable if we are pinging 1.1 to 1.2, but it will not be applicable if we are pinging to another subnet 1.1 to 2.1 from one network to different network. This will not work.
Yeah, it
This
broadcast and it says like it is not in my network, then it goes to default gateway.
correct. Actually, what will happen on this layer itself? It will check. Hey, what is the destination IP? This is not in my network. This is not in my network. So if not in my network, then in the destination MAC address,
Sir, before ARP, it check the switch MAC, like a switch MAC table, right? To check whether this MAC address is in my,
no,
no?
no. See here, let's have a simple diagram.
Mhm.
Switch are connected. One PC1, PC2 is connected. Fine. This having IP 192.168.1.1. This having
1.2.
192.168.1.2. Let's understand this first then.
Yeah.
Within a network. Then we will discuss different between different network.
Okay, sir.
Okay. So because the two different things are there. 1.1 and 1.2. You are pinging in your same network
Mhm.
and your PC knows about it because your PC knows subnetting. Remember this.
Mm.
Whenever you run ping command on your command prompt,
Uh-huh.
okay, what will happen? First, a request message would be there, ICMP request message.
Yeah.
Then on the layer 3 itself, IP protocol will attach the IP4 header. The source IP 1.1, destination IP 1.2. Fine. Then
Yeah.
on the layer 2, source MAC address AA. Destination MAC address, do you know? No.
No.
Right? So
Yes, sir.
on this layer, how can your encapsulation be completed? No. So that's why we have a ARP protocol. Okay, ARP protocol, now it's a responsibility of ARP protocol to find out MAC of 192.168,
One dot
1.2, 1.2.
two. Yeah.
Okay. Hmm. So ARP will do what ARP will do. ARP will initiate a request message to find out the MAC address, in
Mm.
which he will add 192, what is the source IP, who is sending 1.1, towards what? 1.2. What is the source MAC address? AAA. The destination MAC address unknown. Unknown mean for a unknown MAC address, it will apply something. Otherwise, he cannot send the ARP. So he will apply unknown.
Yeah.
Unknown means 00000.
Yeah.
Then on the layer 2 itself, the Ethernet header will be attached by ARPA protocol. In that, source MAC address will be attached. Source MAC address would be AAA.
Mm-hmm.
And then destination MAC address. Now ARPA will know, okay, ARP is sending this initiate message, then it will be broadcast to all. FFFFFFF. It means broadcast. This message need to be broadcast
So,
because
sir,
he
here
need to
the
find out the MAC
frame.
address.
Okay. So here
This,
the frame is going. I mean, Ethernet frame is going along with payload as ARP, right?
right, the ARP
Mhm.
request message only.
ARP is like a payload here.
Yes, it's a
Okay.
not a payload, but we do not call it payload, but it's a ARP
Mhm.
request message. Nothing is there in the payload.
So in this, it's a layer two, right? In layer two, oh, I mean, it's a frame. They call it as frame, right? When
Right,
this
right.
frame is going, they put source MAC address, and we don't have destination MAC address, so we broadcast it, and along with that, we put our protocol, right? In that same Ethernet frame.
Come again.
Is that is in that same Ethernet frame, layer two Ethernet frame will travels right here because there is no packet
This
at.
will, this
So
will, this will.
so in that
Hmm.
frame, along with the Ethernet MAC address,
Hmm.
broadcast like like destination MAC address is broadcast.
Hmm.
Along with that, there will be like ARP, right? The
Right.
three will be traveling.
No, three need, only two. First, this is the ARP request message.
Mm-hmm.
Now it will get encapsulated on the data link layer itself. This is my Ethernet frame. So it will complete. You will call it one frame.
I mean, in that same frame only ARP is there. So first ARP, then first ARP will does this it's traveling and everything. Then it come back. Then this one is finished or like I didn't get that point. So
Which point? This point?
yeah, I mean along with this frame, the ARP will travel. So like first ARP will travel, then the frame will
No, no,
travel.
no, 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 no. This will be on the hold. Now forget about this thing. Your packet will be dropped.
Mm-hmm.
Okay, your first packet will get dropped.
Hmm.
Okay, that's why your first packet always get dropped.
Yeah.
This is nothing now. This is dropped. So simultaneously, what happen if it doesn't have the IMAC address? So ARP will come into the picture.
Yeah.
ARP will initiate. Okay, let's find out the MAC address of 112 because you don't know. Then you
Yeah.
cannot complete your encapsulation at the data link layer.
Yeah.
So ARP will come automatically. One doctor will come. It's like that. Okay, you have some diseases. Let's find out.
Mhm.
Okay, so he is just finding out the MAC address of 198.168.1.2.
Yes,
He
sir.
is sending a request to 1.2 with a source MAC address. Destination MAC address he doesn't know. Now it get encapsulated by the data link layer itself. Source MAC address and the destination MAC address. Destination we do not have. So whenever we receive our request message, it always get broadcasted. So that's why
Yeah.
FFFF will be there. It's in their coding. We cannot change it. This behavior.
Yeah.
Now your this ARP request message will come on to the switch. Switch
Mhm.
will read this. Okay, this message is for FFFFFF and came from AAA.
Mhm.
Came from the AA MAC.
Yeah.
So what will it will store the AA MAC address. Suppose this is a port number 1, port number 2, port number 3. It will what the switch will do? It will make or it will update the MAC table. Like on the port
Mhm.
number 1, there is a AAA,
Yeah.
right? And the switch 1, okay, this message need to be broadcasted. So switch 1 will broadcast to switch 2 all and switch 3 as well. Switch
Yeah.
2 will read it. Okay, what came here? It came here, okay. It is for 192 to 168, the ARP message. I am not 192 168 1.2. Let
So it
ignore
will
it.
not reply.
PC2 will understand, okay, 1.2, AAA, okay, this is for me. In the destination IP, my IP is there, this is for me. Okay, he needs the MAC address. I'll give you. So
Yes, sir.
PC2 will give a ARP reply. In the ARP reply, what will do? BBB, no, what 192 168 1.2. This is sender, right?
Yes.
2 receiver 1.1. Source MAC address here, BBB.
Yeah.
Destination to whom we need to send AAA.
Yeah.
And it will again encapsulated by data link layer. Source MAC address is BBB and the destination is now he knows the destination AAA. Fine. This will come on to the switch. Now switch what will do? He will check the destination is AAA. It will check, switch will check in his MAC table AAA on the port number 1. On the port number 1, it will send toward the PC1. So PC1 will update the ARP entry in his ARP table. Okay.
When it's ping second time, it pings straight away instead of for raising ARP request because PC1 already have an ARP table.
First time your packet you might have seen like your first packet always get dropped.
Yeah. In that case, it is doing ARP request, right? In the
Right.
first packet.
Right. Correct.
Okay.
Correct. Correct. This process is going on.
Yes,
If your
sir.
packet dropped, first packet dropped. When you get now this PC has the MAC address of the 192.168.1.2. Now again the second packet will be there by ISMP request message. Source IP address 1.1. Destination is 1.2. Source MAC address is AAA. Destination MAC address is BBB. This is your ISMP. This
Mhm.
is your IPv4 header attached by IP protocol on layer 3. And these detail will get added by ARPA protocol on the layer 2.
Yes, sir.
Now it will go to the switch. Switch has already created one entry earlier when he was getting a reply from the switch PC2 BBB. The request came on the switch. Switch will understand, okay, it need to send towards BBB port number 3. So it will send here. And PC2 will reply back. And your
Yes,
PC,
sir.
you can see, you can see the ping bit from between the PC1 and PC2. So this is how ping and ARP works. If you have any query,